Okay, so first thing we'll do is talk a bit about how a sensor is getting exposed. And therefore the camera has two modes of operation. The first mode is what we call the pre-exposure mode. And the pre-exposure mode is entered when you are depressing the shutter button halfway. In this condition, the mirror is in a down position, the sensor is not receiving any light, and the curtain is closed. Light will travel through the lens. It will hit the mirror, which will then reflect the light upwards into the prism. The prism bounces the light backwards toward the viewfinder, and finally the light is reaching the human eye. Now you're able to see your object through the viewfinder, and most likely the camera has achieved focus at this moment in time if you were using autofocus. Depressing the shutter button in full will force the camera into the exposure mode. In the exposure mode, the mirror is flipped upwards, and light can travel through the lens and illuminate the sensor. The duration of the illumination of the sensor is determined by the curtain or the shutter. The shutter will open up and close. The time it's open depends on the shutter speed settings of your camera. The amount of light is also determined by the diaphragma in the lens. A big opening means lots of light. A small opening means a little bit of light. Now, light consists out of photons, and these photons are charged particles. They will hit every pixel of the sensor and create a small charge in the sensor. Now, every pixel will then have a specific analog value for that charge. A lot of light means that the pixel is having a high value. A little bit of light or no light means that the pixel has a very low value for the charge. So now we've seen how light is getting to the sensor. But that's not the end of the story. The sensor is now fully charged with pixels. And somehow we have to be able to read that information out of the sensor. That is the role of the capture. The capture will read the analog value of every pixel. Now our device is a digital device, and if it wasn't, we would be shooting with film. The capture has produced an analog value for every pixel. So somehow we need to convert this analog value for every pixel to a digital presentation. That is the role of the analog to digital conversion. Some cameras will have 16 bits, others 14 bits, other 8 bits to represent the analog value. Of course, it is expressed in a binary form. The value of all the pixels in a binary form is then forwarded to the raw processing engine. That is the most important element within the camera. The raw processing engine will create the picture through interpolation. Now remember that the sensor is basically colorblind. And the only way we can create color pictures is by putting a Bayer filter in front of the sensor. A Bayer filter is a patchwork of red, green, and blue fields. And as such, specific pixels will get red, green, or blue colors. But it's still not a color, it's still a quantity of light. It is exactly the interpolation that is happening in the raw processing that converts it to a color picture. Once the color picture is produced, it's passed on to a high-speed buffer. That is internal memory in the camera. The high-speed buffer allows you to continue shooting even though the picture has not been written yet to the memory card. And the reason for that is that memory cards are slow, and if we had to wait for the write function to complete to the memory card, you would be sitting there a few seconds before you could actually shoot your next picture. And finally, you can display your picture on the back of your camera. Now, this can either come from the buffering or directly from the memory card. Now some of you will say, well, this is all fine, but what about JPEG? And what about TIFF? Well, all cameras work in RAW. The fact that you've selected JPEG means that after the buffering and before the writing to the memory card, the RAW file will be converted to a JPEG format, and then it's written to the memory card. And the same thing applies for TIFF. Now all this is highly complex, but in this specific video we'll focus on the sensor technology, CCD versus CMOS, and the capture technology. And you'll see that all these statements about what is better, what is worse, are not true anymore. It is very complex, and we cannot just say in one word that one is better than the other one. So bear with me on the next couple of slides.